So first of all, let me introduce myself. So my name is David Woodland, and I'm the Chief Scientific Officer for Keystone Symposia on Molecular and Cellular Biology. And I really want to thank you all for coming. This is a tremendous turnout. And I want to welcome you, and I want to thank you all for coming. I was just saying that it's really a tremendous turnout, so we're really excited to see everybody here. And I want to welcome you to this community forum on breakthroughs in Alzheimer's research, which is brought to you by Keystone Symposia. Before we really get going, I want to thank Colorado Mountain College for providing this facility for us. We're really grateful to them. And I also want to thank Mary Jo Roll and Yvonne Pasela for helping put this event together. They put a lot of work into it, and we really appreciate all of their efforts. For those of you who don't know much about Keystone Symposia, we're a not-for-profit organization, and our mission is to connect scientists and accelerate the pace of biomedical research. To that end, we convene really high-level scientific conferences in the full range of the life sciences. And we typically organize somewhere in the order of 55 to 60 meetings every year. Many of our meetings take place globally, so many places throughout the world. But fortunately, we do a few in Summit County, particularly in Keystone, but some in Breckenridge. And we take advantage of those local meetings to bring some of the eminent scientists that are attending those meetings to do these community forums. And we've done several of them, and I think they've all been generally very, very successful. It turns out that we're currently hosting a meeting on Alzheimer's disease at Keystone, at this conference center there. And we've brought together many of the world's leading experts on Alzheimer's disease. And so, therefore, it's a tremendous pleasure for me to bring three speakers from that conference to you today, and they're going to talk to you about the latest developments in Alzheimer's research. And I think you would all agree that Alzheimer's is something that touches us all. It's the most common form of dementia, and there's no cure. It progresses relentlessly and eventually leads to death. And critically, it poses a tremendous burden on families, caregivers, and our medical system. But this conference that we're holding in Keystone really tells us that advances are being made, and I think there are hopes, perhaps, for a cure in the probably distant future, but sometime in the future. Hopefully the efforts that are being, conference that's being held in Keystone will help accelerate those efforts. So for this evening, we've brought three speakers from that conference to talk to you. The first of these, on my left here, is John Trojanowski, Professor John Trojanowski from the University of Pennsylvania in Philadelphia. John is actually the lead organizer of the Alzheimer's conference in Keystone, and he did a tremendous job in putting that conference together. And John also led an effort to make a documentary on Alzheimer's disease, Facing the Facts, which was broadcast on PBS. In the middle is Professor David Holtzman from Washington University, St. Louis. One of his claims to fame, in addition to being an eminent scientist, is that he appeared on the Charlie Rose Brain series in 2012. And then on my far left, I have Professor Richard Mayo. He is the Gertrude H. Sagivsky Professor of Neurology, Psychiatry, and Epidemiology at Columbia University in New York. So I especially would like to thank the speakers for taking the time and the energy to come here and talk to you today. And with no further ado, let me ask Dr. John Trojanowski to take the podium.
Thank you, Woody, and thank you all for coming. I'm going to be very brief because what I want to say is captured on a brief little video, 4 minutes and 30 seconds, so you'll see in a moment. If you haven't noticed, we are in the midst of an epidemic of Alzheimer's disease, and you'll hear in the film, putting that into perspective of the longevity revolution, you'll understand Alzheimer's disease is increasing as the age of our population increases. There is some good news, however, maybe a while before there's a drug. But it seems as though lifestyles are associated with cognitive good health, and that's what I'm going to tell you about right now. I use the video because it's got some interesting background illustrations are fun. Everywhere, people are living longer. Adults in industrialized nations now can live an average of 80 years or more. Indeed, 50% of babies born in developed countries today can expect to live to be 100 years of age. And old age ain't what it used to be. The rates of chronic disabilities among people over age 65 have been decreasing for decades, which is wonderful news. However, we have to appreciate that in the last 100 years, since Alzheimer's first identified the disease that bears his name, the rate of older adults who will lose their memory, their functioning, and their very selves to Alzheimer's disease will continue to climb. With global birth rates on a steady decline as fertility declines, today's babies will grow to adulthood in the near future in a world where fewer and fewer young people are available to bear the financial, emotional, and other burdens of caring for greater and greater numbers of older adults debilitated by Alzheimer's disease. This epidemic is the defining natural disaster of our millennium. However, our likelihood of aging well or not isn't something that's predetermined absolutely. It's not all in your genes, although genetics do play a role in how we age. A number of people take the somewhat somber or fatalistic point of view that genes determine everything and there's not much that can be done to counter these aging-related disorders. It's true, the genes that we are born with are the genes that we have, and so you should choose your parents very carefully. Of course, that's not possible, and while we can't select our genetic makeup, there are meaningful steps that we can take now to create the environment within and around us that will increase our likelihood for enjoying a long life with brain health as we age. Exercise is the most powerful intervention yet known for sustaining and improving cognitive function in older adults. Cognitive function improved the most in those who engage in combination exercises. So, for example, aerobic exercise like swimming, biking, or brisk walking combined with strength training or weight-bearing exercises. Of all cognitive processes, executive function, that is the command and control operations of the brain that help us plan our daily lives, are most improved through exercise. Merely exercising 30 minutes a day, 3 or 4 days a week, so that we break out into a sweat, is deemed by many to be sufficient enough to reduce our risk for cognitive impairment as we age. We'll get the most out of our bodies and out of our brains if we're properly fueled. We need to think about our diets, and a heart-healthy diet also works as a brain-healthy diet. So you've got to build your menus around fresh vegetables and fruits and proteins like fish, poultry, beans, and whole grains, and minimize your intake of saturated fats such as those found in red meats, butter, or oil. Another thing is social engagement, and by that I mean interacting with people. The richer our social network, the less likely we are to encounter cognitive impairment as we age. So get out there and be active in your communities. The other important factor is cognitively stimulating activity. Couch potatoes are at greater risk for cognitive impairment than people who play mahjong, who play cards, who read the newspaper, and you don't have to buy expensive computer games. And did I mention, if you enjoy a glass of wine, that's also deemed to be beneficial for reducing cognitive impairment. Studies suggest that persons who drink moderately, about 1 drink per day, are less likely to develop age-related cognitive problems. Avoidance of head injury, of course, is important, and we need to minimize hypertension, obesity, metabolic syndrome, and heart disease. That's also a risk factor for cognitive impairment. Adopting a healthy brain lifestyle at any age, I want to emphasize, may help many of us reduce or delay the effect of age-related changes in our cognition and our function. So it's never too late to embrace the lifestyles that I'm talking about. However, it will require more than what I've just been discussing to have an impact on Alzheimer's disease. The development of new drugs and effective therapies that halt the pathology of Alzheimer's disease before the symptoms appear is going to be the way forward if we are to realize the possibility of lifelong brain health for all.
Well, I think the video that John just had made and showed us all is a good lead-in to a brief introduction to make sure everybody here is on the same page. So let me just put some definitions to some of the words that were in the video just shown. So dementia, the word dementia means a decline in memory and other cognitive abilities that is sufficient to impair your normal function. Lots of different diseases of the brain can cause dementia. We're talking today about Alzheimer's disease, which probably contributes to maybe 70-75% of cases of dementia in the United States. So it's obviously the thing that has gotten the most attention because it's so common. At age 70, only about 2% of people have dementia. But over the age of 85, it's about 50% of people. So this is a huge, huge problem. And it's been estimated that the cost of caring for and taking care of people with dementia and Alzheimer's disease now exceeds that of cancer and heart disease. So this is a really big public health problem. Because it's getting people live longer, the regular medical care is so much better, it's becoming more prevalent than it was before. So from this, I think one of the things that I wanted to stress in my brief presentation is what's changed about how we think about Alzheimer's disease over the last few years. So when I was first in medical school about 30 years ago, we didn't really understand much about what really caused Alzheimer's disease in terms of the underlying brain changes. What's happened over the last 30 years is that we now know that Alzheimer's disease, like some of the other diseases that are kind of like it, appears to be caused by proteins that our brain makes that build up in the brain abnormally. So normally proteins are made in the brain, they're cleared away, but in Alzheimer's disease, two particular proteins build up and they seem to damage the brain. One of those proteins is called amyloid beta. That seems to kind of build up first in this disease, and then another one called tau builds up a little bit later. And both of them together really appear to be instrumental in causing the brain to degenerate. Now, I think I remember when I first saw a patient with Alzheimer's disease, they were very demented, like many people you've seen, like in a nursing home. But when I started to see people when they first were presenting with memory loss, usually the first symptom of Alzheimer's disease is memory loss, I began to wonder, what is really underlying the initial changes in the brain that we can see when somebody first starts having change in memory and thinking. And it turns out one of the major, I think, advances the last 20 years is that if somebody has very, very mild cognitive decline that is due to Alzheimer's disease, if you look at a person's brain, which now you can do by imaging or by looking at other markers in the spinal fluid, you can now determine that that is not the beginning of the disease. The pathology that I was telling you about, these proteins that accumulate in the brain, start to accumulate about 15 years before any symptom of the disease is present. So, and once they start to accumulate, they build up, and then by the time you're symptomatic, you actually have memory change, you've already lost a lot of nerve cells in the brain. So I think one of the major challenges now is to use some of the newer technologies that have been developed the last few years, which is now being done in research studies, to define who is actually developing Alzheimer's disease before they're symptomatic. And the hope is, and this is now just beginning to happen, is that you could take people who we call have preclinical Alzheimer's disease, meaning the disease is starting, but the people are still completely normal. And to put them in trials of some new promising drugs that are being developed or agents that might be treating the disease to see if you can actually delay the onset of any cognitive decline at all. And I think given the course of the disease, that by the time you're symptomatic, there's already a fair amount of damage in the brain, a lot of people believe that that'll be the way to really have a major impact on the disease over time. And so I think I'll stop there, and then I'm sure there'll be some questions in our question and answer period. I think Dr. Mayu is going to talk to you about some of the genetic aspects of Alzheimer's disease that lead to some of the things that I was just telling you about.
Thanks, David, John, and Woody for inviting us. I practice neurology, and I've practiced it for about 35 years in New York City. And I see a lot of patients and their families. And the most frequent question I get after we've discussed the diagnosis is, did I inherit this? Is it in my family? And are my kids at risk? And so family history really is a very strong predisposing factor. It's especially strong if you have a sibling with the disease. The more siblings you have affected, the more likely it is that your risk is increased. Many people have a parent that they remember having had dementia or something like that. Because it's such a common problem, it's not unusual to have a parent or a grandparent who may have had the disease. That doesn't necessarily mean your risk is any higher than the average person who didn't have a parent with the disease. But if you have a sibling, or if a parent had several siblings with the disease, your risk is increased. So family history is important. What we've learned over the last 2 or 3 decades is that there are 2 types of genes that are related to Alzheimer's disease. And we classify them simply into genes that cause the disease, they're deterministic. If you have a mutation in a mutation changes what the gene product is. Genes make proteins, so the gene mutation affects the protein that it produces. Those are deterministic genes, and they cause a rare form of what's called autosomal dominant or dominantly inherited Alzheimer's disease. Dominant inheritance means that either the mother or the father can pass it on to the subsequent generation. Every child born to a parent with one of these deterministic genes has a 50-50 chance of developing the disease, and both men and women can transmit the disease to the subsequent generation. But those are very rare. They account for less than 1% of all the cases. The majority have what are called risk genes. These are risk-raising genes, and for a long time the only one we knew about was something called apolipoprotein E, or ApoE. Probably everybody in this room has heard of it. And I'm looking at the audience. Most of you are Caucasian, and 25% of the people in this room have the ApoE4, which is the risk-raising form of this gene. That means that you have a increased risk of developing Alzheimer's disease, assuming you live to about age 85. Now, that's the big assumption, that you have to get to 85 to fully empower that risk. If you're unfortunate because you get 1 copy of the gene from your mother and 1 copy from your father, if you happen to get an E4 from your mother and your father, then you're what we refer to as homozygote. Your risk is very highly increased, and it's almost tenfold increased over people who don't. Now, having said that, there are plenty of people that have ApoE4 that don't get Alzheimer's disease. In fact, there's a study going on right now of people that have 2 copies of ApoE4 and have somehow escaped the disease. And that's a very interesting group of people that we're interested in studying. Now, to make things even more complicated, there are 23 genes that scientists have identified now that are all that raise the risk of Alzheimer's disease, but by a tiny amount, maybe 10 to 20%. So you might say, so why should we be interested in that if they're only raising the risk a little bit? Well, it's our belief that we need to identify all these genes because they don't act independently. They all act in some sort of network. And every time we identify one of these genes and the protein that it produces, it tells us a little bit more of the puzzle. If you imagine one of those 1,000-piece puzzles that you fill out, that you put together when it's raining outside, and imagine that it's a forest with nothing else but just trees and leaves, that's kind of what we're doing. We're putting little pieces of the puzzle together to try to figure out what the main cause of this disease. And it's likely that these genes work in a network. The other thing that's really interesting, and I mentioned this already, we're also using this genetic data to identify people who have somehow escaped. For example, I follow a group of families that have a particular mutation, one of those high-risk mutations. Some people in those families get the disease at age 30, but some people in the same family get the disease at age 70. So how does a mutation cause a disease in somebody at age 30 and then protect somebody for 40 years to age 70? So there's a group of these families, and they're under intensive study, just like the ApoE44 people are, to try to find things that protect people from getting Alzheimer's disease, somehow allowing them to survive without the disease. And that would help us identify potential targets that maybe we can convert into a drug. So that's the story about genes and family history, and I'm happy to take questions when the question and answer series comes along.
Okay, we'd like to take questions from the audience, and we have a microphone that's going to be handed around. So just put up your hand if you want to ask a question. We've got a microphone for the speakers, and they can pass that microphone around.
Thank you. I was wondering if you see very often a patient that is kind of a dual diagnosis that has Alzheimer's, but also maybe Lewy body or frontal temporal. Or
Maybe I'll start with that, and if anybody else wants to answer it differently or add on. So Alzheimer's disease is very common, as we've talked about, but another disease that also causes dementia that's relatively common is called Lewy body dementia. It has disease that you probably must be familiar with that causes a syndrome that looks like Parkinson's disease, but you also get dementia with it as well. And Alzheimer's disease combined with Lewy body dementia is pretty common to see them together. That's probably the most, the other thing that Alzheimer's disease frequently co-occurs with is cerebrovascular disease or strokes.
And maybe I'll just ask, that's a very, very good question, because it's so critical for the drug discovery and clinical trial efforts that are ongoing, because we just had a discussion of that today, and some of the clinical trials have had 20-30% of people in the trial treated for Alzheimer's disease who didn't have Alzheimer's disease. It wasn't as though the physicians weren't brilliant, they were, but some dementias look very similar, and having a biomarker to tell you whether it's the plaque and tangle type of dementia or some other kind of dementia will really improve the efficiency, cost of clinical trial, etc. So that was a big part of our discussion today. So you've asked a very good question.
Do you differentiate plain dementia and Alzheimer's, or is Alzheimer's just a form of dementia?
Alzheimer's disease, as Dr. Holtzman, or David Holtzman said, is the most common form of adult onset dementia. And we make a diagnosis there. Our methods, including spinal tap with spinal fluid evaluation, PET scan, MRI, and cognitive testing, that we can differentiate various forms of dementia. We're right about 90% of the time. Sometimes we don't exactly get the form of dementia. Somebody might have dementia with Lewy bodies and initially only show manifestations that look like Alzheimer's disease. But eventually we get the diagnosis correct.
So it's a lab diagnosis or an X-ray?
It's a combination. It's a clinical diagnosis supported by laboratory studies.
Some of the things that are happening now that will really make this a lot more accurate is already happening, is that by looking, as Dr. Mayu said, at the spinal fluid, certain proteins there, also with brain imaging tests, where you can actually image the proteins that accumulate in each of these diseases. In the next years, I think what will happen is that we will make a very, very specific diagnosis in everybody. Right now, insurance doesn't pay for a lot of these tests because there's no proven treatment, but they're becoming available, and this will change over the next few years.
I'm 85, and I'm beginning to do a lot of forgetting. Is it important to know, should I get my neurologist to test me for various things to see if I have Alzheimer's or something else? Because I know that I'm forgetting a lot now. And it's been about, a year or two that I've been gradually forgetting. And I sure don't like it.
That's a good question. I think it's really important when there might be changes in memory like what you're talking about to get evaluated. And typically the thing to do is to get seen by somebody who does have experience in seeing patients who are developing memory or thinking problems. And it's also very helpful to go to see a physician or somebody who is expert in diagnosis with someone that knows you well, so that the history can be obtained not just from you but from somebody else at the same time.
I might also add, though, that sometimes we find things that we didn't expect. For example, you might be taking a medication. Some sleeping medications do affect memory performance. So it's always important to look for other possible correctable changes that would affect your memory.
I'll just mention if depression sometimes can mask as dementia, and there's a few treatable, they're rare, but treatable, hypothyroidism, for example, vitamin B12 deficiency. I would also hope you'd be excited by what you saw in the film, that so at Penn we have a cognitive fitness program for people with early onset Alzheimer's disease, as well as the normal controls in our study, because they're older and they want to improve their cognition. So many of the things that I illustrated are part of this cognitive fitness program, which the subjects find a lot of fun in addition to benefiting from. So there's a number of reasons why you might want to engage to find out a little bit more about what's going on with your memory.
Does Alzheimer's cause death? And if so, what is the pathophysiological mechanism? Does Alzheimer's cause death?
Interesting that the three of, I'm a neuropathologist, so I do a lot of research on living patients, biomarker research, but I am the person who would look at the brain and determine if it was Alzheimer's or something else. And our death certificate system in the United States is not accurately registered. The fact that people who have Alzheimer's disease die of Alzheimer's, they'll list pneumonia, not uncommon for people to develop an aspiration pneumonia when they're in stages of the disease. So I think Alzheimer's disease is a very malignant brain disorder, no different from cancer, other highly malignant conditions. Much like cancer, you don't die because every cell in your body becomes neoplastic or cancerous. You die of a pneumonia or inanition and other secondary consequences of the disease. But I'll be curious to know what my colleagues to the left would say.
I agree. I mean, if you get to the point where you're severely demented, you can no longer take care of yourself, even if there's a nurse constantly there all the time. And so people tend to die from having aspiration or getting an infection. But it really is the Alzheimer's disease is causing the person to die by those other mechanisms because they can't take care of themselves anymore.
Is there any degree of memory loss with aging that would not be considered dementia, or is any even the sleep, forget where you put your keys down without automatically?
Yeah, I hope forgetting where you put your keys or these is not, because I have 12 pair, and that way I never forget where they are. No, it's when it's, I think really the key thing that always, I think, triggers for me is when someone repeats themselves often and are completely unaware, and because we all forget, we're all busy people, we have a lot to remember, we have a lot of things to do, and everybody loses their keys or can't remember where they put the pen down, or go into the kitchen because your wife told you to go there and you don't know why, you can't remember why she sent you there. But when it's over and above what you would normally expect, I think that's when people get worried and they should get some evaluation for that.
Since there's obviously a protein element to this disease, have they ever done anything with plasmapheresis on patients to put?
I can't see. Oh, right there. That's a very good scientific question. There are people have thought about doing that, although there hasn't been a trial, a formal clinical trial. There was a recent trial done where instead of doing what's called plasmapheresis, where you, as you said, you exchange the materials in plasma and let it dialyze away to get rid of like bad humors. Something called IVIG. So where intravenous immunoglobulin pooled from people was given to people to try to treat disease, thinking that it might remove some of the amyloid beta that's accumulating in the brain. The trial was negative, although it was done in people who already had mild to moderate dementia, so pretty far along in the disease. So it's not clear whether that would really work as more of a prevention or not.
And David works a lot on cerebrospinal fluid and its dynamics in the brain, so he'll, I think, remember this study about 10 years ago. Dr. Sternberger from Stanford did a study in which there was a drainage of cerebrospinal fluid from the brain. You may be aware that some people have brain conditions that require a shunt, so it is invasive. You have to put a tube into the abdomen, but it's certainly tolerable. It's done for a number of different conditions, and that was not successful. But I think we're all beginning to be aware that trials in moderate Alzheimer's disease patients may not work, yet the same medication or intervention possibly could work as a preventative or an earlier stage. So a lot of the thinking is shifted. Hopefully we'll find something to treat people with moderate or severe disease, but a lot of the thinking has been towards prevention. There's a number of exciting new trials that I'm certainly read about. David's leading one of them, or his group is leading one of them at WashU on the prevention. So treating people who don't have a memory problem, don't have a memory complaint, but show those biomarkers of cerebrospinal fluid or imaging measures that the pathology is on board, and we want to stop it from continuing before they result in nerve cell loss.
Hi there. Are there any advances in anything that can be done once someone is diagnosed with Alzheimer's?
There are. So right now, at least from a medicine standpoint, there are some medicines approved for treating Alzheimer's disease. There are two classes. One is called cholinesterase inhibitors that increases the concentration of a memory and attention-enhancing neurochemical called acetylcholine in the brain. And those drugs, like one of them is called donepezil or Aricept, there's other ones, they do have some effect on the symptoms. They aren't game-changing. They don't suddenly make you normal again, but there is some effect, and I think most neurologists that specialize in this agree that it's worth giving patients that type of medication. There's another medication called memantine that affects another neurotransmitter in the brain called glutamate, and it also appears to have some effects in more moderate Alzheimer's disease. Again, not major effects, but some. And then I think the movie you just saw shows that even if you already have dementia, participating in certain lifestyle things like getting good exercise and cognitive stimulation, even if there's already dementia, is very helpful.
Question. In addition to the eating healthy, exercise, and limiting one alcohol drink per day, are there any food supplements that can be recommended that will help in preventing?
I don't think there are any. There is a constituent in red wine called rotenone that has become very interesting for the pharmaceutical companies because it may be a potential therapeutic for neurodegenerative diseases. You would have to drink a case of red wine, though, to get enough on board to have an effect. So obviously the pill form is going to be preferable to most people, I would guess. But I'm not aware of any supplements that, you've heard about fish oil and vitamin E and so forth, but I don't think they're proven to be.
What I tell there's a lot of things that have been tested in animal models that seem to have some benefit, but in human studies, there really is nothing that's been proven that's helpful. So it doesn't mean it would hurt to take things like fish oil or other things, but there's no proof that they're helpful at this point.
I've been reading that there might be a correlation between gluten intolerance and diseases that you're discussing, that if you're gluten intolerant, you become allergic to it, and the allergies do something to the nerve. Any credence in that?
I'm aware of that. Some people have speculated it's been in the lay literature, but not in the medical literature. The studies in there are a number of medical conditions that are associated with Alzheimer's disease, but in particular, it's cardiovascular disease and diabetes. Those are the two, and they do so by having a direct effect on the brain. But people have both vascular disease in the brain and amyloid pathology.
Since it sounds like prevention is the key to the long-term goal of decreasing Alzheimer's, are drug companies and scientists working on developing a test that would show up the amyloid B as a marker in people, so this could be a routine test? And then secondly, I hope drug companies are working on developing a drug that would decrease the formation of the amyloid B.
I'll take that to start. And so there already are tests that can detect, that have been developed, that can detect the amyloid beta when it builds up in the brain. One of them is a kind of a PET scan that you can see where it's building up. And then you can also look at the same protein in the spinal fluid, and that can tell you whether or not the protein's building up in the brain, even when you're still normal. And the drug companies are actively been working very, very hard with other academic institutions to create drugs that either decrease the production of amyloid beta so it doesn't build up, or increase the clearance of it from the brain. So that's what the major billions and billions of dollars have been put into that in effort to do exactly what you just asked.
So they are working on, besides the spinal cord and the brain imaging, a test that could be used simply on blood before symptoms occur to see if you are starting to develop this protein.
Yes. So people are trying to develop blood tests that would tell you the same information as the imaging studies. Nothing has been published that's overly convincing that it will work yet, but I think it's likely in the next few years, it's very likely something will probably work in the blood. There's some things that are promising, but not as advanced as the imaging.
You had mentioned, sorry, you had mentioned that one drink or about that was positive. Where does the curve change? 2 drinks, 3 drinks?
So this is a long literature that you've got to read through to come up with some real facts. And people, have certainly studied red and white wine. There's no difference in the beneficial effect of red versus white, even though I mentioned the rotenone in red wine. It's not clear if other types of liquors have the same beneficial effect, beer and scotch and so forth. I don't follow this literature as closely as biomarkers and other things, but I've spent some time looking at it. I think, 1 or 2 drinks certainly is not going to hurt you. I'm not advocating, binge drinking or anything like that. And no one is. That it's really drinking in moderation is the key.
So the question is really, do you see that binge drinkers or heavy drinkers may increase?
So alcohol can be toxic, and there is a disease called Wernicke-Korsakoff syndrome that is due to alcohol toxicity. So heavy drinkers would succumb to this disease, which causes parts of the brain to degenerate, including parts of the brain that are involved in memory. So too much alcohol clearly can be toxic. There's a fetal alcohol syndrome that affects the kids that are born of moms who are drinking excessively. So we know it can affect people throughout the lifespan. Alcohol can in excess.
So, Professor Trajanowski, are we far enough along to know that it's the protein that causes the problem, or is that just a side effect of, that's just a marker of something else going on? And the second question is, I'm really blown away that Alzheimer's and Parkinson's has got some kind of correlation, common denominator.
So I'm going to do something that I often do for people who don't, get what we're talking about when we talk about protein misfolding. So the proteins in our bodies are made by genes. You've heard about that already. And the proteins are what I would call the action figures. So take insulin. It helps move glucose into a cell. So you've got to have the insulin in its proper shape, engaging a cell that has a receptor to bring glucose into the cell. So for proteins, shape is very important. It may not have occurred to any of you, but what I have here is my agenda for yesterday. It's written on a piece of paper, and I would urge you to think of this as a protein, conveying information. So just that like a protein, this piece of paper contains information. I can read it right now, what's on there. But if I go like that, it's now become misfolded. So it's lost its function. It can't do what it normally does, that is enable me to read my agenda for the day. And so when the A-beta peptide becomes misfolded, or the tau protein or the synuclein protein becomes misfolded, just like I've illustrated here, there is a loss of function that can occur. We know this in great depth and detail for tau. We're still struggling with understanding the functions of A-beta and synuclein. And if I were to do this for the next year in this room, I'd fill this whole room with papers. Just think of that as an analogy to the process that David talked about earlier. When the disease begins, the brain junk, the A-beta and the tau accumulate for many, many years before there's enough mass to start killing cells, or enough of it to start killing the cells that carry out the functions of memory and executive decision-making and so forth. So in brief, I do think my strong feeling is that these proteins are the bad guys, and a lot of the therapies are aimed very simply, I can illustrate them for you, as blocking the folding that I just illustrated, or unfolding the misfolded proteins so that they're back in their proper shape again, or throwing them in the trash waste compactors that all cells in our body have. So that's my very brief answer to how I think about Alzheimer's disease and the protein misfolding problem.
So you doctors can't come to Colorado without talking about marijuana. So the latest studies with a certain form of marijuana that can be used to help treat epilepsy. Any comment?
I don't know enough about the specific studies, but one of the things that is known is that the brain has cannabinoid receptors, and the brain makes endogenous cannabinoids. And so it's easy to think that if a molecule that normally is in the brain is being put into the brain exogenously and it stimulates receptors on nerve cells, that it could potentially affect the excitability of nerve cells, which is what overexcitability is what causes epilepsy. But I don't know the specific studies you're referring to. I haven't read them carefully enough to comment about how good they are, but you could easily envision how that might happen.
So the question is, do statins affect? So the epidemiological literature is all over the place. So there was a report out of England that people who got statins didn't get Alzheimer's disease. Then there was the reverse, where people who did take statins had some cognitive impairment. It was taken into the laboratory and was shown to statins could affect A-beta processing in study animals. Then there was a trial, and the randomized clinical trial showed no effect. So keep taking your statins if you're supposed to take them, but they're not going to prevent you from getting Alzheimer's disease, and they probably won't treat the disease if you do get it. They're very good for cholesterol, though.
There's one question there. Yeah.
Could you guys comment on any research about traumatic brain injury and Alzheimer's?
I know several people at our institution, John has also thought about this a lot, but I would say that the one thing that has come out more recently in the last few years about traumatic brain injury is that if it's significant enough, it appears to initiate, in particular, a form of pathology that you also see in Alzheimer's disease, where this protein called tau accumulates where there's injury. And what appears to, if the injury is significant enough and you have repeated injuries, for some reason, that tau protein not only accumulates where the injury was, but it starts to spread around the brain. And that appears to be leading to the dementia that sometimes occurs with chronic brain injuries.
And I think what you're probably thinking about is the NFL sports injury more than anything else, and I think that's what David was referring to. There's lesser degrees of injury that may also be significant. So one of the most robust environmental associations with dementia is head trauma. And one of the best studies that was done by Barbara Plassman of World War II soldiers when there was better documentation of their episodes of loss of consciousness or not, with a non-penetrating brain injury, so not, they didn't get were struck by a bullet, but just an IED or something equivalent to that in World War II that knocked people out. So that study in about 1998, I think, showed a very strong correlation with the severity documented in the field of head injury and cognitive impairment. I played football. I never had a loss of consciousness. I was thrown off my horse when I was 16 and had an episode of loss of consciousness. I think I'm still normal, but those are the kinds of lesser degrees. Those are the kinds of lesser degrees of head trauma that they're very difficult to parse out in terms of their impact on one's long-term risk of Alzheimer's disease.
So I have a question on. So there's a lot of proteins that appear to build up in the brain. Amyloid B, tau, ApoE, synuclein, whatever. I haven't heard that one before. Are there any commonalities between those proteins?
So they all undergo this protein misfolding problem for reasons that are not clear, but we know that the mechanisms that I alluded to, the refolding, is done by a chaperone mechanism. It has an appropriately sounding name because they're supposed to take care of the proteins so they don't misfold, much like a chaperone would for a school dance or something like that. So we know that many proteins in our body that are made do misfold and get refolded. So that's the body's figure out a way to deal with that because it happens so commonly. Or they can be put into the trash compactors that has very specific names and do very particular tasks. What we don't know is, why these proteins, among all the others in the brain, that that misfold. We know that mutations can cause this, but in the absence of a mutation, it's not clear why synuclein or tau or A beta are so much more prone to misfold and accumulate when other proteins don't.
Well, the only thing I would say is that there's been many proteins, no matter how long you live, will not misfold or aggregate, and some do. And some people have studied the commonalities that what you're asking about. And even though the amino acids that make up a protein, the sequence, are different between amyloid beta, tau, synuclein, and other proteins that misfold, there are some features that are similar in the part of the protein that misfolds, meaning that they tend to have features that are kind of called hydrophobic, meaning they will bind well to oil, and also hydrophilic, bind well to water, and they have both of those features together. And so proteins that have certain features like that, if they're around long enough, can have a propensity to misfold. And there's some researchers that can really kind of predict from the amino acid sequences which proteins more or less likely to do that. And then when they're tested, that's really what happens.
Have you guys heard anything about the use of coconut oil for Alzheimer's? I've heard that they think perhaps it's the medium chain fatty acids in the coconut oil that are causing a positive effect.
It's very popular on the lay internet cycles, and it's never had a clinical trial. If you read the person who's promoting it, and he has references, they're all his reviews. None of them are scientific randomized trials. It affects your cholesterol level. I don't know that it's safe. So I don't recommend it at all. You can't just read everything that people put in these lay information sheets. Look at the references. If the references are from the same author, you got to be a little suspicious. And that's one I'd be very suspicious about.
I'll just add one comment. Our economy spends $55 billion a year on anti-aging potions, lotions, balms, and salves that have no proven efficacy. And I have said, when people challenge me about where the money will come from for Alzheimer's research, well, there's $53 billion right there that's being wasted. People enjoy indulging in these creams and so forth, but they don't have any efficacy whatsoever. And there is, unfortunately, an institute for anti-aging medicine that I think is made up largely, I think I can say this, of charlatans who are pushing products that they have company investment in. So be careful when you read these testimonials who they're coming from, as Dr. Minio said.
You've talked about the genetic predispositions to Alzheimer's disease. I'm wondering if there's any associations with either racial, ethnic, or geographic regions of the world. I'm particularly thinking of places where longevity is characteristic, such as in Japan and Okinawa particularly. Has anybody looked at that in detail?
Yes. So far as we can tell, every ethnic group that's been studied has an equal propensity of developing the disease. There's one key thing. In countries where the life expectancy doesn't go past 60, they don't have much Alzheimer's disease. And I work, for example, in a geographic isolate, an island called the Dominican Republic. People don't migrate there. They migrate to New York sometimes, but mostly they stay on the island. And for the first time, their life expectancy has increased. And this is a small country with 13 million people. 1 million are now over 65, and they're in panic because they have all these cases of Alzheimer's disease coming out. So it affects every race. There was some literature a few years ago saying that in the Asian islands in Japan, there was more of a vascular component, and there is some truth to that. There is more vascular disease in that group, but there is also equally Alzheimer's disease. The genes are interesting because we all have the same genes. What we have are different markers within those genes that make us either taller, gray hair, no hair, blonde, brunette, whatever. And some of those genes that affect Alzheimer's disease, the form of the gene that causes Alzheimer's disease in a Caucasian may be a different form of that gene in another population would cause Alzheimer's disease. A very recent example is a gene called TRIM2 that was found a mutation that causes Alzheimer's disease. In African Americans, the mutation that they describe doesn't exist, but there's a marker adjacent to that mutation that is associated with disease in African Americans. So it's very important to study other ethnic groups because we can learn what the genetic driver is of that gene.
And the National Institutes of Health is looking at some of these populations, Sardinia, I don't know for sure about Okinawa, where there are long-lived, longer than average-lived populations. I know a little bit more about Okinawa. It's the poorest prefecture in Japan, and usually longevity tracks with wealth. So this is an exception to what is the general rule that as socioeconomic conditions improve, people live longer. The people in Okinawa embrace those lifestyles that I showed you. They work their entire life. They never retire, and they do farming. They do hard work. They do fish. They're fishermen, and they eat hardly any meat. So fish and a lot of vegetables. And they have, I'm sorry, I can't remember the Japanese term, but they have a thinking that says you should never leave the table full. You should always be, about 70% full, but not completely full. So they're not doing caloric restriction, but their survival advantage may be because of the lifestyles that I've referred to before and just mentioned now. So these are important things. There's probably a genetic contribution to that we just haven't discovered. But
I just wanted to talk a little bit about diet, specifically sugar, and you were saying that heart disease and diabetes are contributing factors to Alzheimer's. So in the Western diet, we have a lot more sugar than probably, in Japan and other Asian cultures. Do you think sugar specifically is bad?
Well, certainly obesity is a risk factor for Alzheimer's disease, and so there is an obesity epidemic, as you know, that could, increase the statistics or the prevalence of Alzheimer's disease. There have been several reports that you may be aware of, I believe from Denmark and the UK, that people currently in their 60s or 70s are experiencing declining rates of dementia, not by a lot, and it may be because they've stopped smoking, gotten the message about heart health and proper diet and so forth. I don't know all of the reasons, but it certainly could be that people of that age group have made lifestyle and dietary changes that are leading to a measurable decline in dementia. I don't know if David or
well, I think specifically the question you're asking is about sugar. I think the reason likely that sugar can be bad not only for heart health and but also for Alzheimer's disease is because if you take in excess processed sugar, you're more likely to be overweight, and also you can become insulin resistant easier. And I think those are how that could contribute later to Alzheimer's disease.
And there have been several studies of epidemiological studies where they look at cohorts and they do either a food frequency questionnaire, they ask people what they eat, and then they can compute micro and macro nutrients and estimate dietary factors. And pretty much all of those, even the ones that have the questionnaires supported by some bioassays of vitamins, they pretty much show that there's really no specific dietary factor that causes Alzheimer's disease directly. It's the intermediate step that Dr. Holzman was talking about.
Making sure you stay healthy. I have heard people refer to Alzheimer's and Parkinson's, at least the cognitive portion of Parkinson's, in the same breath. Could you elaborate on any correlation that might apply there? And also, I thank you very much for your comments. We could hear you better when you hold the microphone closer to your head. Thank you very much.
Well, both Alzheimer's and Parkinson's so Alzheimer's is the most common cause of cognitive impairment, and Parkinson's disease is the most common neurodegenerative cause of a movement disorder. So those are the two, there's 5.5 million Alzheimer patients in the United States and about 1 million Parkinson patients. And so common things being common, it's not unlikely that someone would have, Parkinson's or Alzheimer's, but it seems, or together rather, but it seems as though the coincidence of both occurs at a much higher rate than would be predicted by chance alone. So there may be something interacting in the genes or among the proteins, and I don't want to bore you with details, but we've been able to, use tau to make synuclein misfold and the other way around. So there is some sort of interaction that could perhaps explain the predisposition of Alzheimer patients for Parkinson's and vice versa. And we know that 80% of Parkinson patients will develop dementia in the course of their illness, which in most cases, 70%, 60% is due to the Lewy bodies, the signature pathologies formed by this misfolded synuclein that early on impairs movement. Those pathologies migrate to the parts of the brain that are involved in thinking, and then people develop dementia. So, and Alzheimer patients can frequently have the shaking, the tremor, the rigidity that is the clinical manifestation of Parkinson's disease. It's a very intriguing question that many of us are looking at.
Can you speak specifically more to the benefits of exercise related to dementia in what you're seeing with recent studies in the brain?
I'll start, and then maybe others want to. I think there's two things that may be going on. One is that people who exercise more tend to, of course, then develop less of the risk factors that predispose to Alzheimer's, like less obesity, less diabetes. So that's one factor. But there's actually been studies in animals that show that if you exercise, you take a group of animals that's predisposed to get some of the changes of Alzheimer's disease, and you exercise one group and you don't exercise the other, that exercise somehow actually reduces the amount of Alzheimer's type pathology in the brain of the animals. That is probably distinct from cardiovascular health and other factors. So those are the two things that I'm aware of. I don't know.
I think it's really fun to go back and figure out how they associated exercise with better or lower risk of Alzheimer's disease. There was a study in the University of California in women who were being watched for osteoporosis, and one group of women were asked to walk a mile every day, and another was just given information about their diet and things like that. And the study was called Women Who Walk. And somebody was clever enough to do a cognitive test in both arms of the study and figured out that the women who were walking not only didn't get osteoporosis, but their memory was better. And that started this whole series of studies. There are at least, I don't know, there must be 20 or 30 clinical trials now registered at clinicaltrials.gov that are randomized trials across the country looking at exercise. And there's a couple of them in our institution. And I don't know whether it's helping their memory, but they all seem to be having a great time. And I think it's a combination of the physical activity plus the social interaction that really enriches their experience.
Thank you. Which one do you feel is the higher risk? Is genes, like we have an uncle, a father, and now son? Or is it lifestyle, or is it your environment that would be the number one cause?
So your question is, are genes more important or is the environment more important? And I don't think we know enough yet to say which one's more important. And the reason, a few years ago we were looking in the environment, and the problem we had in the environmental studies of communities, and there's several large epidemiological studies looking at risk, is that they were inconsistent. So we would find one factor that seemed to increase the risk, and that would make it into the New York Times in my part of the country. And then somebody would come around a few years later and do the same study and not find the factor. Then we got the wise idea from our colleagues in basic science that it depended, and when they tried to do this in animals, it depended on the strain of the animal. So then we started figuring out that maybe there's an interaction between what somebody's genetic makeup is and their exposure to these environmental factors. So now it's swung almost back to the beginning, where we're now looking at all these large studies. I would say almost all of the large epidemiological studies in this country have now had genotyping done. And so the effort is to try to figure out which are the important genes, then go back and look at every one of these studies has had detailed information about diet, smoking, alcohol, etc. To go back and look at gene-environment interaction. But you need thousands of people to do that. And the reason is, just like I said, ApoE4. 25% of the population in this room has an ApoE4. Okay, so let's say 10% smoke, right? So I'm looking at 10% times 25%. We can figure that out. That's the portion of the people that have the double exposure. So that's 2 or 3 people. So you need a study of 20,000 people to really understand whether this gene environment is the important factor. But I think that's where we're going to get there. That's the optimistic view. We're going to solve that problem, but it takes numbers.
I think my question was actually right along those same lines. If my dad's mother at 67, got Alzheimer's, passed away from it. My dad now has Alzheimer's. My sister's freaking out. Is there something we should do, or is there some sort of test that we can, I almost don't want to get tested. I don't want to know. I told my husband he's got 20 years, and after that I won't remember. But, is there something that we can be doing? Is there something that we could get tested? Is there something that says, do you know what I mean? What is there for those of us that are watching all this happen?
Well, one thing you could do is volunteer for one of the research studies that are being carried out. So that's probably the one thing that you could help the most with, because I think what will happen is once these studies start coming out that determine that, let's say, somebody who's pre-symptomatic, that's predisposed, that there's some treatment that will actually make, let's say, help you, prevent you from getting disease, then everybody should get tested. But at this point, getting tested is really just being done in research studies, because we don't know what to tell you other than to lead a healthy lifestyle right now.
I think this is so important to emphasize that participating in clinical trials is really, really important. You look at us as the scientists and maybe you think we have the answers, but we can't find them without you. It really is a partnership, and this works so much better, I think, in many parts of the United States than I've seen it play out in Europe, where there isn't this kind of interaction of scientists with advocacy groups, with patient groups, with communities. This is why I'm here tonight. I'm passionate about what I do. I want to make as many other people passionate about curing Alzheimer's and Parkinson's as I am, because I can't do it alone. I need a big team back at Penn, but we can't do it at Penn by ourselves. We've got to work with these folks here, and they're our friendly competitors. We compete, but we're also collaborating a lot. But we need to bring you all into this too, and we're not going to do this without your participation and help. So that's a plug for.
How do you get involved? Contact your senator. Contact your congressman. It really does come from you. Oh, for clinical trials. Well, you can do that too. But you can go on the web and do that. And in fact, if you have a family history, if there are people in your family, there's a national study that I direct. We've collected about 1,600 families across the U.S. Dave and I are involved in another study of young onset Alzheimer's disease. But one thing we do is we make the DNA and the clinical information anonymous to any scientist who wants it. In fact, the collection that I've put together is the most widely used genetic samples in the country, and I think sometimes in Europe they use it as well. So you can get involved that way. And to answer your question, we probably see a lot of people like that. I'm sure there are people in this part of the country that would see you get a baseline evaluation, get some counseling, understand what your risks are, and it's always good to get a good starting place because sometimes you worry more about things that really aren't really happening. You're just worrying, and that would help.
It depends whether you want it for a clinical reason or for research. If you want it for clinical reasons, then typically you'd go to a neurologist to get a cognitive evaluation. But if it's for research, depending on where you live, most major academic medical centers have research programs that are related to what we're talking about. And if they don't, they can tell you where would be the closest place to go.
So I promised that these guys would be able to get back to their meeting. There's a poster session going on. So I know that there are a lot more questions, but I'm afraid we're going to have to shut this down. But before we do that, I actually have one question, and I'm going to take my prerogative.
Can we take one special question for the lady?
Oh.
Go.
Yeah, so on the NIH website, you go to then a subcomponent of that website is the National Institute on Aging, and they list their different studies going on around the country.
Thank you. So I have one quick question. So I have a brother with Down syndrome. So he's about 52 years old, and my understanding is that Down syndrome is associated with a very high incidence of Alzheimer's. And just incidentally, he shows no sign of it, but it's a very, I know normally it's a very high incidence. Is there any understanding of why that might be the case?
So everybody with Down syndrome, if they live long enough, will get Alzheimer's disease. But the age at which the actual dementia starts is quite variable. The average age is about age 50 of the dementia, but the pathology of Alzheimer's disease starts pretty early, but by the mid-30s, it's already well along the way, the neuropathology of the disease. But some of the just like in late onset Alzheimer's disease that we see all the time, there's probably genetic and other factors that cause somebody with Down syndrome to get the disease earlier or later. So for example, ApoE4 can cause people with Down syndrome to get the disease a little earlier. Maybe ApoE2, which is protective, may cause it to occur a little later.
And they have an extra copy of chromosome 21, which is the gene that the amyloid precursor protein resides on, that when processed gives rise to A beta. So they have an extra dose, and we know from other studies of other rare duplications or triplications of genes that just, an extra copy of the synuclein gene or the APP gene can predispose someone to familial hereditary Alzheimer's disease in early onset. So that's not the case of Down syndrome, undoubtedly, why that's the case.
Well, thank you all very, very much. I really want to thank the speakers, John, Richard, and David, for participating in this event, coming over here and answering your questions. I think they did an absolutely spectacular job. And I hope you all have a very safe trip home. Thank you.